Okay, so let's continue. So now going back to the fractional factorial design approach. So it allows us to significantly reduce the number of experiments. So to basically to make sense of what's happening, let's go through a simple experiment in which we have k number of variables. Okay, and so k is the factor number for us, and each of them can take n levels of n different levels. So if I go with a full factorial approach, I have to multiply these n, basically n1 times n2 and so on. But because all of them are equal to each other, it's going to be n to the power of k. Okay, so let's say in the experiment about healing, let's say I had 4 different temperatures and 4 different times. So basically, instead of 1, 3, 5, I had 1, 2.5, 3.5, and 5. Okay, so 4 cases of time, 4 cases of temperature, 16 cases. But, or it could be another experiment in which I have, like, let's say, about the lift, calculating lift. I have the cross-section of the surface area of the wing, velocity, and density. Let's say each of them can take 3 different cases, 3 different levels. So I'm talking about 27 experiments. That's 3 to the power of 3. I have 3 variables. But now, if I use my theories, whatever I understand, to confound these two, to basically say the variation of each of these is on its own is not important, as long as rho u squared remains constant. In other words, this is the variable I need to choose. So I confound how u and rho are contributing in this case. So now, so then I'm reducing 3 to 2. Now I have 2 variables. So basically, I have 2 variables. I have rho u squared and I have a. And if each of them takes 3 different cases, basically I have 3 different cases to the power of 2, I have 9 experiments. So these are not considering the repetition of each experiment or replication of each experiment, but compare this 9 to this 27. So indeed, the fractional factorial can significantly reduce the number of experiments and can reduce it by this factor, which in our case, we went from 3 variables to 2. So, so basically, we reduced it by 1. So p is 1 in this experiment. Look at here, k minus p. So k was 3, and it's reduced now to 2. So p is 1, and n is the, well, I have 3 iterations, 3 levels in each parameter for each factor. So it's reduced significantly. It's when things are multiplied like that, reducing even one of these n's makes a huge difference. So look at that. And so as an example is brought to you here that we have 5 variables. We reduced the number of variables, but we confounded them to 3. So basically, and each variable has 2 levels. So just to be clear, so level for each variable is 2, k is 5, and we reduced it by 2. Let me color code it. So this 2 is this 2. This 2 is the amount we reduced it by, is this one. And there's just 1 5, so you can is imagine what's happening. So the number of experiments in this case is dropped from 32 to 8. It's a huge cost saving. And now this allows you, just like what I mentioned to you, this allows you to identify the combination of variables that are very important. Just that I explained to you here, that rho u squared is very important. And so with this, we can identify regions within our data set that the output is changing a lot. And now we can zoom into that region and do another fractional factorial design. So basically, for instance, if I just want to show it in case of two variables, imagine the case where I have one of my variables is taking 6 different cases, and I have another variable that is taking 4 different cases. So altogether, I have to run 24 experiments in this area. Now, imagine there's another factor that I have that takes 5 different cases that comes out of this board. So altogether, 2, 4, 6, 7 times 4, altogether 7 times 4 and times 5 that comes out of this board is the number of experiments that I need to do, 140 experiments. But now let's say instead I use the factorial approach and I investigate a sub-region of this 3-dimensional space, and then I identify where the output is more sensitive to the variables, and I further dig into that region. So this concludes our summary of design of experiments, and there will be one homework that I will share with you on this subject. And thank you, and we'll be in touch.